This Zoom session is being brought to you by the fractal Octaves Z. All right, for today we finished chapter 2, which means I guess that chapter 2 is, you may hand it in starting next Tuesday. This section is phase shift, where a wave, we move left and right a little bit. That's the phase. Sort of like how the seasons go autumn, winter, spring, summer, autumn, and so on, run in a circle. However, which season it is, that's the phase of the year. It's in this form. We start with a function, an equation y equals a sine omega x plus phi. That's an omega, not a w, though it looks like a w. And this is the Greek letter phi. And this phi is what gives you the phase shift. So here's what you do. You pull out from these two terms inside the sine. We remove a factor of omega. We get a sine omega times x plus phi over omega. Or we rewrite that a little further as a sine omega times x minus negative phi over omega. This phase shift, this negative phi over omega, is the phase shift. It's how far left or right we move the sine wave. This will have a period of 2 pi over omega and an amplitude of a that we covered before. But this, like I say, shifts the wave a little bit. And similar with a cosine omega x plus phi, we have amplitude absolute value of a, period 2 pi over absolute value of omega, and phase shift is negative phi over omega. Now that we can do a few shortcuts on phase shift. If we shift the phase of a sine wave by 2 pi, that gets you right back to where you were. And a cosine of omega x plus or minus 2 pi, also cosine of omega x. So we have a period 2 pi. And if we add plus or minus pi, sine turns to minus sine, cosine turns to minus cosine. So this is a half period. That's a little more complicated when you have pi over 2. If you add pi over 2 inside the sine, that becomes cosine. And subtract pi over 2 inside the sine, you get minus cosine. If you add pi over 2 inside the cosine, you get minus sine. You subtract pi over 2 inside the cosine, you get sine. So there's a pi over 2 phase shift between cosine and sine. Or in other words, pi over 2 is a quarter of a full cycle, a quarter of 2 pi. Now we have some examples. That's the graph 4 sine 2x minus pi. Well, this minus pi just turns this into a minus 4 sine 2x. And then we can just go from there. Amplitude is 4. Period is 2 pi over 2, which is pi. No phase shift. So we start from x equals 0, plug it in, you get 0. 1 full period, pi is 0. Halfway between a 0 and a 0 is another 0, pi over 2. And between the zeros are peaks and values. Now, okay, with a sine, since it started at 0, 0, you have to actually plug in x is pi over 4 to find out what exactly, if it's plus 4 or minus 4. You plug in pi over 4, you get 4 sine pi over 2, and sine of pi over 2 is 1, so you get 4. This is, we have a minus 4, you get a minus 4 here, and a half period later we get a 4 here. So this goes from 0 to minus 4 to 0 to plus 4 to 0, like that. The period of pi, here's one wave, here's a second wave. Here's 2 sine 3x plus pi over 2. Well, I could use this business about if you add a pi over 2 inside a cosine, that'll just be a minus sine. But I'll do it the other way. So we pull out a 3 and get 2 sine 3 of x minus negative pi over 6. So you have an amplitude of 2, a period of 2 pi over 3, and a phase shift of negative pi over 6. So this is shifting the phase of a cosine wave. So we'll start at negative pi over 6, and if you plug it in, this cancels. 3 times 0 is 0, cosine 0 is 1, times 2 is 2. So at negative pi over 6, it's 2. 1 full period later is 2/3 pi. If you add 2/3 pi to pi negative pi over 6, you get pi halves. So it goes from 2 to 2. Half a period is pi over 3. You add pi over 3 to negative pi over 6, you get plus pi over 6. So a half period is 2 to -2, and then back to 2. And midway between the peaks and the values are the zeros. So halfway between minus pi over 6 and pi over 6 is 0. At there, it's 0. Between pi over 6 and pi over 2 is pi thirds. There, it's 0. So it's minus 2. Is this a positive 2 to 0 to -2 to 0 to 2. That's one full cosine wave. And here's another full cosine wave. And there's your graph. Here we have y equals -3 sine 2x plus pi over 2. Here I'll use that pi over 2 trick. Sine of something plus pi over 2 is cosine of the something. So we can get rid of that phase shift a little bit. And what do we have? Amplitude is absolute value of -3, +3. Period is 2 pi over 2 is pi. So start at 0, plug in 0, cosine 0 is 0, cosine 2 twice 0 is 0, cosine 0 is 1, times -3 is -3. So it goes, and if period is pi, so from 0 to pi, it goes from -3 back to -3, like that to that. Halfway between the values is the peak. At pi over 2, it's 3. Midway between the peaks and the values are the zeros. So midway between 0 and pi over 2 is pi over 4, where it's 0. Midway between pi over 2 and 3 pi over 4, it's 0. So there's 0 here and here. So -3 to 0 to 3 to 0 to -3. That's one wave, and here's another wave. Here we have y equals -3 sine -2x plus pi over 2. Okay. Again, sine, if you add pi over 2, it'll just get you the cosine. -3 cosine -2x. Cosine is an even function, so this negative gets absorbed. Get -3 cosine 2x. And all right, we can read off of that. The amplitude is 3. The period is 2 pi over 2, which is pi. And, well, we can go from there. At 0, next is 0, cosine 0 is 1, times -3 is -3. -3 to 3 to -3 through these zeros. One full period is pi, a half period is pi over 2. Midway between is here the pi over 4 and 3 pi over 4. So -3 to 0 to 3 to 0 to -3. That's one wave, and here's another such wave. Now here we're going to go backwards. They want to find the equation of a sine function with amplitude 3, period 3 pi, and phase shift -1/3. All right, now it's of the form a sine omega times x plus phi over omega. Amplitude is 3, so the absolute value of a is 3. Now, okay, I really should say a is plus or minus 3, and we have to check which one it is. Here, omega is the period 3 pi, or rather 2 pi over omega is the period 3 pi. So if you shift around things, omega is 2/3. And -phi over omega is -1/3. So, well, 3 sine of 2/3 of x minus a -1/3 plus 1/3. So 3 sine 2/3 of x plus 1/3. Now I have to admit that this is actually not sufficient information. This is really plus or minus 3, and so this should be as well. The +3, it starts going up, then down, then up. Where the -3 goes down, then up, then down. So actually this is insufficient information, and really there's two answers to this problem. But okay, that's for now. Let's turn this off.